So good morning, everyone. Thanks for joining today. We'll start with the we'll start today's lesson. Today's lesson is a continuation of yesterday. So we will still keep learning about R. So what I will do is I will share my R Studio screen. Okay, so if you open RStudio, you see that most of you can see that the environment is empty. If maybe some of you see that you still have the variables, but this is because I think if you go to Tools and click on Tools and then in the drop-down menu Global Options. I have you see in general in the workspace I have disabled that restore our data into workspace or startup because this is in case that we are working with large data sets. We don't want to save the memory in the into disk, so that's why I have this set to never, and I have untick this option. So in my case, I need to load again the the file. So I needed to save in Sharebase, read the CSV and the file. Well, here I get an error that says that this function cannot be found. This is because I forgot to load the library. The library is tidyverse. So, but yeah, it's easy. Let's load the library. Tidyverse. Yeah, and now if I read the file, okay, it works. And I see that now in my environment, I have the data. Okay, so what yesterday we stopping we work with that data frame, and we were indexing, getting columns, rows, values, but what we will see today are facts. What is a factor? A factor is uh, you have a, for example, for the species, you have a certain number of species. So in this case, you can define the instead of having characters, you can define it as factors. So factors is when you have in the documentation mentioned that is categorical data. And the sample that is in the documentation is with the in our surveys the sex of the animal. But okay, well, let's start with an example. We have when we read the file, we create the surveys, the columns get this could be double character, and we can change one column to a factor. So let's start with that. And to change a column is you type surveys, Then you type a dollar symbol, and see you get all of these, well, you get all the column names, but we're interested in sex. So now the arrow and is a factor, and the argument is the column that is surveys dollar sex. So if I execute that, and now I do a summary of surveys dollar sex, I get that because in the sex we only find two values. We find F for a female, M for male, and also we have some missing data. And also the explain that the factors are sorted by alphabetically. So when you have we have here this example, we can create a factor, and we will create this factor in the variable called sex. So to create a factor is you type a factor and you introduce a vector with the elements that, for example, in this case, we will have a male and female. We will have these strings. And internally, these strings are changed into integers, or into where the different in R, the different the different elements that you can have are called elements. Elements are called levels. So we have the function that is called levels. If we execute that, we see that we have two elements. We have a female and male. And also n levels, we'll get the number of levels that we have. So we have two. Also, if I introduce a sex, they give me the whole vector, and we get the levels that are female and male. Also, it's if we want, we can change the order when we create our vector. That is is a factor. We introduce the vector that we have created before, that is a sex, and we can specify levels. That the levels are C, and here I specify male, female. So if I print again sex, we see that the levels now are in the opposite order, are male and female. So I mean, the using factors is good for. We will see later that we can for plotting and for some to do some statistics are more convenient. Okay, to learn, to practice a little bit with the factors, I will paste a challenge. Yeah, okay, I will Well, there is a question that is to post the command to import the file. Is I will copy that in the chat. Say this one. Oh, sorry. So this is to get the file into memory. And the factors, sorry, yeah, I didn't explain quite well. Uh, we have several types of, we can have numbers, so that could be a double, integer. We can have strings, and also we can have a factor. Is when we have some elements that mm, we have it's called a categorical data. It's when we have a set of elements. For example, for sex, in this case, we have a male and female. So we have two elements, and we will not have more. For we will see that now for the, for example, for the species, we may have 10 elements, and we will not have more. So instead of saving that using strings, we will convert that to factors. So these elements will be mm, categorizing, well, we will have different levels, and each level will correspond to a, internally is saved with a number. So instead of using from 1 to 10, let's say, we give names to these indices, to these. So this is why I put this example that we can create for this column of surveys sex, we can create a factor. And if I do the summary, if I see the column, we see that we have two elements. We have a F for female and M for male, where NAs are, as you know, missing data. So it's a way of getting of categorize data. So I'm not sure if now is more clear. What I will do is I will put some exercises, and you may understand better what a factor is. But if not, please let me know, and I will try to. It's yeah, it's like a bit tricky to explain well what a factor is. And also, if you see, if you go to environment, you see that you have a you see that, for example, we have a sex, this is a factor, and we have this is a factor with two levels, that is a male and female. And if you see internally, this is saved in integers. For one, I think it's okay, two levels male female, so male is 1 and female is 2. So internally save 1, 2, 2, 1. And why is using that? Because you will not have any other levels. Later you can add a new level, but well, we will see that. But you only have two levels, so it's a way of uh, have this variable, and this is also good because uh, you get an error in case that you try to save another level. So that's the idea. It's like a tool to make this to make data handling more powerful. That is in C. There is something similar, but now I don't remember the name. But this concept is similar. Okay, what I will do is I will copy in the chat the challenge. Uh, Let me see if that's Okay, so in the chat there is an exercise that is change the columns taxa and genus in the survey's data frame into a factor. And also, if using the functions that we have learned that are summary, labels, and labels, see how many rabbits were observed, and how many different genera are in the genus column. I'll give you 5 minutes, and when you are done with the exercise, please let me know in the chat. So for the link that I copied, you need to remove the space that are between the bar and end loaded. I will show you I will copy that link in the here in the source. So you see that there is a space here between this bar and end loaded. If you need to delete that and execute this, and if you do that, you download that file here. Okay, so what we will do is we will let's solve this exercise together. So the exercise says change the columns taxa and genus in the service data frame into a factor. So before we have done with the with sex, we have done surveys, dollar symbol, and we okay we use sex, but in now we will use taxa. Assign, and is a factor, and again the column that is surveys, dollar symbol, and taxa. And we'll do the same with the genus as well. So what we will do is well, let's write the surveys, dollar symbol, genus, factor, and the surveys, dollar symbol, genus. Okay, if I print the structure of surveys, we'll see that okay, some columns are numbers, characters, but you see that for sex we have a factor with the two levels, F and M. And now for genus, we have a factor with 26 levels that are all the different genus that we can have. And for example, for the taxa, we have a factor with 4 levels because we have a bird, rabbit, and 2 other levels. And you see now that well, before taxa were characters that are rodent. But if we use factors, it's easier to understand. We see like we have 4 levels, and they will not be other factors or other types. Would be a bird, rabbit, and two others. So yeah, it's a convenient way to for the for some columns that the data could be categorized is a good. And okay, now that we have this survey with this new structure, we need to answer two questions that are how many rabbits were observed. So what we can do is we can use the function summary. Oops. Yeah, that one. Summary and the column. Well, column. We can print the. Mm, well, we can print the. Is a what this is a genus. Ah no, that's okay. We get a different. Uh, no, it's a taxa. Sorry. So there we see that for taxa we have four different types, four different levels. Bird, rabbit, reptile, and rodent. You see that are short alphabetically. And for rabbit, we see that we have 75. And also the other question is how many different genera are in the genus column. So we can see the uh, levels of surveys at the genus, and we see that we have 26. Also, if we want to see what these 26 levels are, we can print them, and we see that we have these 26 different genera. So, any questions regarding factors? Not, we will continue playing with this. Also, because we have if we get this, for instance, well, okay, let's use better this factor that is smaller sex. We have a vector that is for male, female, female, male, and we have but this is the type are not a string or are not integer. It's a factor for two levels. But if we want to get to convert that to a string, we can do that. We can use as dot character sex, and we see that now the output is a vector or strings rather than a vector of factors. And also what is a good thing that we have for the when we use factors is that it's quite easy to plot them. You can use the function plot, and you can plot surveys symbol sex, and in that case you have in that in the here you have the plotting of the. Not sure if that well, if you want to see this bigger, you can click here in zoom, and a new window will open with the plotting. Okay, yeah, there is a question that the yes, because sex, I have already defined this. Uh, well, okay, to see it's easier if I click here in history, I can see what I have executed so far. So I have defined the variable called sex. That is a factor of well, sex is not the first I define this sex. It's a factor, and I introduce a vector with two different elements. You have, well, are four elements, but are two types: male, female, female, male. So this is what I have executed. And yeah, again, the function factor, you give the argument is a vector with the elements, and they find the factors for you. Uh, and here what I explain is because takes alphabetically but in case that we want to have change the order and have a male, female, we can have we can specify the levels. Well, we see in this plot that the elements that are not the missing data is not introduced in the here. So what we will do, okay, also what we will do is we will define the sex. I mean, we will do a copy of the column sex of surveys into the variable sex, because we will play with that. We will do some modifications. So we'll do that. Sex, we will assign the column service, the column sex of a service into sex, and we will start playing with that variable. So you see that in the plot is missing this well, we can do the summary of sex. I will see that we have that number of females, males, and we have data that is missing. If we want to include that data as a new level, we can do so. Let's we can see the levels of sex are F and M, and what we can do is we can do sex add NA. Sorry, yes, sex. So if I execute that and I print again levels, we will see that now we have a third level that is called NA. And we can, if we print again, we see that we have a third column that is the, well, NA, but here is not represented. What we can do is we can change the name of the of the level, the new level, because we have a how to change the name. So we can do levels sex. We can use this like okay, when we do that, the output is a vector, so we can modify the the name. If we modify the third element of that vector, we assign the string undetermined. Undetermined. So if I plot again, I get now this column is have the new name. And also we can do the same with to change we can change the F and M with the female and male. So how can we do that? Same, we do levels, sex, and we see that F is the first element. So I assign female and the same with the male. If I print now the levels, oops, we have these three levels, female, male, and determine. And if I plot, well, this is because it's not big enough. Yes, now I see this. If you click here in Zoom, you see a larger version with more definitions, like a little bit. Okay, I see that there is a question that my axis labels are showing messy codes that are in the category. Maybe because if you do I'm not sure if this is maybe because of the variable is the variable could be different. You can see in the environment, you can see that to see if there's what is the value that you have, the sex. You can see what is a factor with three levels, male, female, etc. I'm not sure if maybe you have was a problem defining the variable sex. Could be. We can have a look at it later. Um, yeah, we can have a look and see. Okay, so well, before I finish with this, is there any question regarding factors? Do you understand mm, what the factor is and why it's like mm, how they can be used? Okay, grand. So what I will do is, well, I will continue, and next is we will now work with the date. That this is like the last part of well the lesson that is called starting with data. So formatting date. So if I see the structure of surveys, we see that we have a month, day, and year are three different columns. But I can what we will do is we will have a new we will create a new column called date using these three columns: the month, day, and year. But okay, first let me explain. We will use the library library date. I think is so. If let's load it, is to load a library. You may know is you type library and the name of the library. That in this case is library date. and we get that warning that the following objects are masked for. What that means is we have the same yesterday when we load the library tidyverse. Date intersect set diff and union. When we execute that functions, they will execute the functions that are in the package or library date, rather than the functions that are by default in R, in the package base. That this is what it means. That means. So a function. Mm, Now we can have a date. So we will define a new variable that is called my date, and I can assign for example, today, the date of today. I can use the function ymd, that this is like you give a string and it converts to a date. So the string is well, first we introduce the year. This is 2021. The month, that is June, so 06, and the day, that is 16. So you see that now we have in our environment a new value that is my date, and is today, the string that I have specified. So if I do str my date, we get that the my date is the variable is a date with that format. Also, we can have for surveys, we have a year, the month, and the day separate in different terms, but that's not a problem. We can that is a function that is called paste, where we can have for instance, we get for today, let's use the function is called paste, and you can have the elements. So you can have a 2021, you can have a 06, you can have a 16, and you can specify. The separator is we will use this dash. So if I use that, the output is the elements that I have introduced, separated by a hyphen or dash. And as you can see, we can create a new column. Okay, let's create that new column. That this is we can create surveys. The new column will be called date, and we will assign. We will use the function. I mean, the function could be used for one element or for a vector. So the function is ymday, like a year, month, day. And we introduce, okay, now we need to use the function that also we have learned, that is paste. So that function also works with the vectors. So we introduce surveys, $symbol year, surveys, $symbol month, surveys, $symbol day, and we need to specify the how we want to separate that. That this is with yeah. And if I execute that, Well, I get that we will see later. We get a warning message saying that 129 elements were failed to parse. We will investigate later why. But if now str surveys, we see that now we get a new mm, but here date, but it's not. And we got now this new column here. And the class is where instead of being a number, factor, character, now is the type is date. And also we can do if we can use the function summary to see surveys date. We can see the minimum, the maximum, and well, we can use that because this is a defined. We have use first the year, then the month, but well, this is like a is a the type is a date. Is not a string any longer. This is only the representation that we have in order to see the. So, okay, there are some 129 dates that are not parsed, and how we can identify them or how we can find. So we can get them. So we can define the variable missing date assign. We can use a surveys. Well, we will use now square brackets because we will get elements from that data frame. And I will get the for the rows, I will get the rows that we have a missing data in surveys date. How we can do that is dot na and surveys date. So this is here we select the rows that are we want this one, these ones, and we will get the output of this will be true, false, and this is for the rows. And for the columns, we are interested in get year, month. Okay, we'll make this a little bit bigger. Day. Let's see if that works. Well, I will print now the first element of missing data, missing date. Okay, so these are the year, the month and day that were not gave an error. So can you see why was not possible to get a date from this for these rows? No, the problem here is, I mean, you can have a dates are not. You can have several dates that are the same, because for the Ah, no, the underline for, no, that's not, I think this is when you, mm, something related when you print the, but yes, I mean, the error is not that, it's not because there are repeated elements. You can have for data, I mean, you can do the sense of the animals, you can do for several days. So yeah, that is little bit subtle to see, but yeah, that's the error. That month is September, and they said that it's the 31st of September. That is only 30 days. For April is the same. There are only 30 days. Like for February, for instance, if you use 30 or 31. So this is also a way to yes to keep an eye and see that if the format is good, or I mean the dates are make sense or not. Because also the date could be, imagine, 50, or you can use the month 13. So it's mm, to see if also is a way to see that the data that we have stored in days, months, and years make sense. That's a good question. That if February 29 is part the way is we can, yeah, I mean we can try and see. I mean that's the way of learning things in R, like doing them. So to do that, let me if we can use that. Well, that depends on the function. Is if R is intelligent enough to know because okay, we'll have a 2021 06. Okay, this is an error. Change if I use 21, 29. Yes, but okay, because this year is February only have a 28 dates, but uh, let me check. So 2020 is a leap. Let me. Okay. Oh, so okay, is it intelligent enough to? So okay, so 29th of February of 2020 works, but if I introduce the same for 2021, no, doesn't work. Well, so yeah, that's takes into account leap years. So yeah, something that new that we have learned. So yeah, R is intelligent enough, or the person or team that wrote the function took into account that. Okay, so any any questions so far? If not, we'll start working with. We will see a little bit more more complex. Yes, how to get how to work more with the surveys with the data frames. We will see how select different columns, uh, how we can work with that data and get the information that we want. So, well, we already have our surveys here, and what we will use now, well, because we have already loaded tidyverse, the libraries that we will use now are already loaded, but we will uh, work now with the library that this is called mm, dplyr, or it's like a type like this dplyr, that library. That this is as well the help says grammar for the data manipulation. So the functions that we will okay, we will start for the easier one is called select. With the function select, we because when I print surveys, we get well, in this case 14 columns, but I want to select only 3 columns. So the function is select. Oops. The first argument is surveys, so the data frame that I want to work, and we can select three columns, or well, the columns that we want. We will select plot ID, we will select species ID, and we will select weight. And we see that we get a data frame with with all of the rows, but we have three columns. Also, if I want to get rid of some columns, we can do we can also use a select. The first is a surveys, the first argument, and the other arguments are the columns that we want. What if I don't want a column? I type minus and record ID, for instance, and I don't want species ID. So instead of the original data frame had 14 columns, we get the same, but without the columns that I specified before, record ID and species ID. So okay, we know now select. Next function from that library, we can use a filter. So imagine that I want the surveys that were done in the year 1995. So that's easy. I can use the function filter. First argument is surveys, and the second argument is the filter that I want to. So it's a year should be equal 1995. So if I execute that, I get the number of rows is a little bit more than 1000, and I get the data frame, but the values that are the entries that are from the year 1995. So yes, we have seen two functions, select and filter, but that is a way That is another way to use these functions that are this is like using pipes. A pipe is the output of a function is the input of the next function. We'll see an example, for example, surveys. If I execute that, I get the following output. But what I can do is that output could be the input of the next of a function. So what I do now is I use a pipe. The pipe is the percentage symbol, um, the this great is small that is smaller than thing, and this symbol. So this is what I use to for a pipe. I will copy that in the chat. So we use that for to use a pipe. And now I can, for example, before I select several, I can do select, and now I don't need to introduce the first argument is not anymore the data frame. I can select imagine that I want to species ID, the names of the columns, sex and weight. So this is a way of doing the output of surveys is the input of the next function. And also you can do also a filter of this. So if you introduce here surveys, the output is now filter. What we will do is the weight should be smaller than 5. The pipe again. And if I execute that, I get the I select the species ID, sex and weight of the species that whose weight is less than 5, and I get 17 entries. So this is the way that a pipe can be used. So what we will do now, okay, let's this part is more interactive, or we have more exercises. I will copy the exercise here in the chat. So the exercise is using pipes subset the survey's data to include the animals collected before 1995 and retain only columns year, sex, and weight. I give you a couple of minutes, and yes, please let me know when you are done with the exercise. Now, so let's solve the exercise together. So okay, the exercise is using pipes subset the service data. So get surveys, and there is a Control Shift M. Yes. If you press Control Shift M, you can write the pipe. And this said that we want animals collected before 1995. Okay, so we need to do a filter and say that year should be smaller, whoops, than 1995. And another pipe, and we want to select only 3 columns. So well, that's easy. Select year, sex, and weight. Oops. So yeah, I see that there are plenty of yeah, a lot of values are not mm, are missing. This is also, for example, for instance, when well, we'll see if we want to do to plot values, or we need to get rid of these values. That's why also R is powerful, because it's easy to filter them. Yes, if we change the order, we get the same. Let's well, yeah, the best way is to try. If you do select mm, year, oops, year, sex, weight, and then you filter uh, year less than 1995, get the same. In this case, it doesn't matter. You can do first a select and then a filter, but we will see later that sometimes we need to use the. Ah, okay, okay, I know what you mean. That uh, yeah, this is a question of style. Yes, it's mm, yes, you can use pipes or you cannot use them. But pipes are when gives more clarity when you execute. When the this is like a quite a long, is like could be more readable. We will see more examples. You will understand like why it's a way of using them, because I mean, the idea of this mm, if we copy and paste here, I think normally you use the pipes like this. So you get the surveys, and then you do the select, and then you do the filter. So when this is like quite long, for example, this is more readable than having everything in the same line. But yes, if you can, yeah, you can avoid using pipes. For instance, if it's you are using only select or only filter, it's up to you. But it's just we are seeing this to yeah, to have more resources in case that enough in the future you find it useful, that you can put this into practice. Okay, so let's continue. We have seen so far select and filter, and the next one is mutate. This is when we have a column and we want to apply some an operate a conversion. The example that is here, we have the weight is in grams, but we want the weight in kilograms. So how can we do that? Is the following: we use a surveys pipe, and we use the function mutate. I need to specify the name of the column that is weight kilograms, that is will be equal to weight divided by 1000. So if I execute that, well, okay, because it's not okay, it's not so because it's at the end of the, but we can do if okay, also we can do another pipe and use head. Okay, no, I need let's do select and type weight and weight and the new so in that case we see that we have a weight kilograms, and we have well, here we have this 218 grams, that in kilograms is 0.218. So yeah, to the way of calculating that is the weight in kilograms is equal to the weight. This is the weight in kilograms. This is the column that we want to create. So it's a weight divided by 1000. Okay, what else is also we can create here we create one column, but also we can create other columns. What I will do is I will copy this better on top of for clarity. I will so I created one column, but I can create another one. I can create weight in pounds, that is equal, and now I can use the previous column that I just created here. So I can use weight kilograms multi oops multiply by 2.2 and I will get weight LB. If I execute that with Control Enter, I get well, I get a lot of missing data, but I get the weight in grams, kilograms, and in pounds. How we can get rid of this missing data? We can do we can filter the values. So we can add now a filter here saying that get rid of the to get rid of the NA values in weight. Sorry, not pipe. And if I execute this, now I have everything. Well, weight in grams, kilograms, and in pounds, and we get rid of the missing data. So this is why, for example, we use pipes of this in one line is like a little bit difficult to read. So if we split that into different lines, is easier. Okay, I will okay, before going for the break, let's do the another exercise. That is copied here, and also will copy the exercise here in the oops, but well, it's in the chat. The idea now is to create a new data frame from the service data that meets the following criteria. Contains only a species ID column and a new column called hint food CM. And the length is in centimeters. And that column doesn't have any missing data, and all values should be less than 3. So yes, do when you are done with the exercise, please let me know. Cool. So I see that yes, some of you have solved the exercise. What I think, not sure if we will have. Yes, because we have the break at 11, but I can explain the solution now. So okay, let's see what the exercise says. That this contains the. Oh well, what we can do is well, let's have a break now. I will explain the solution when we are back at 11:30, if that's okay. You will be like with more energy to understand uh, the the solution to the exercise. So yes, let's have a break and see you at 11:30. We will finish the learning the other functions that this library has, and also we will do a little bit of plotting. So see you in a bit.